everyone, welcome back to Bon Science. Today we are going to be going over Unit 2, Topic 5 in AP Chemistry. So this is actually around the halfway point of Unit 2, so we're almost there. Today's topic is Lewis diagrams. I think this is a pretty cool topic and this is pretty important for the AP, so I really suggest you all watch this video if you want to succeed on that AP Chem exam. So let's get straight into it. So obviously, first things first, you're all probably wondering what a Lewis diagram is. And Lewis diagrams, as the name would imply, are diagrams that show the structure of a covalent molecule. So they are a visual representation of what covalent molecules look like. And for the AP exam, you need to know how to draw them and how to pick up certain properties from them. Today's video will only focus on how to draw them. So today's going to be focused on how to draw Lewis diagrams, and then the rest of Unit 2 is going to be devoted to looking at a Lewis diagram and figuring out what properties that diagram reveals. So without further ado, let's get into the meat and bones of this lesson. So Lewis diagrams can be intimidating. I struggled with them at first, but if you follow a couple of steps, they actually become pretty simple, and I think they become pretty fun. So the first step in drawing a Lewis diagram is to count the number of valence electrons you have in the molecule. So let's do a sample molecule. We'll do CO2. We're going to draw the Lewis diagram for CO2. And remember, it has to be a covalent molecule. So you'll never be drawing a Lewis diagram for like NaCl or MgCl2, none of that, because those are ionic compounds. It's only covalent molecules. So let's take a look at CO2. So if you look on a periodic table, you'll see that carbon has 4 valence electrons and oxygen has 6. And if you're confused on how I did that, I would go review the video on valence electrons, which was back in Unit 1, I believe. Go review that so that you understand your valence electrons. But essentially, you're going to add the valence electrons you have, and remember that you have 2 hydrogens, so you're going to multiply those 6 valence electrons from oxygen by 2, because you have 2 oxygens. Did I say hydrogen before? I meant oxygen if I said hydrogen. And this is a 2. So 4 plus 6 times 2 is just 12 plus 4, which is going to be 16. So that's your valence electrons, 16 valence electrons. So that's step number 1, count your valence electrons. So step number 1. Step number 2, you're going to put the most electronegative atom, or the least electronegative atom in the center. So for CO2, that's carbon. So you're going to put that in the center, and then you're going to put everything else on the outside. So because oxygen, we have 2 oxygen atoms, we're just going to put those on the side of carbon. If you don't know how to determine which one's less electronegative, that's just periodic trends. Go review your periodic trends. The reason we choose carbon is because carbon is to the left of oxygen, and if you remember, electronegativity increases as you go up and to the right. Oxygen is to the right of carbon, so it's more electronegative, so that means carbon is less electronegative, so that goes in the center. One important exception to this rule is that hydrogen never goes in the center. So even if hydrogen is the less electronegative element, you're not going to put it in the center. A good example of this is H2O. When you draw the Lewis diagram for H2O, even though hydrogen is less electronegative than oxygen, it still goes on the outside. And this is because hydrogen can't form multiple bonds. It only has that one S shell. It can only have 2 electrons max, meaning it can only form 1 bond, so it's not going to be in the center where it might have to bond with like a bajillion different things. That's an important exception to note. But besides that, the less electronegative one goes in the center. So you put it in the center, you have your other atoms, just put them around, and you're going to draw a single bond. So in Lewis diagrams, a line indicates a bond. So a bond is 2 electrons. So it indicates that the atoms are sharing electrons with each other, because that's what covalent bonds are, right? So you draw 1 bond. Each bond represents 2 electrons. Next thing you're going to do is complete the octets around the terminal atoms. So the central atom is the one in the middle. The terminal atoms are the ones on the outside. So you're going to complete the octet. So the way you do this is you draw your lone pairs. Lone pairs of electrons are pairs of electrons that aren't bonding. you just draw those as 2 dots, right? A lone pair. So we're going to complete the octet, which means we're going to draw 6. The reason we're drawing 6 is because these oxygens already have 2 electrons from the bond, so they just need 6 more to complete the octet of 8 electrons. At this point, what you're going to do is you're going to count the number of electrons you have. So we have 2, 4, 6, 8 on this oxygen, and we have 2, 4, 6, 8 on this other oxygen. That means we've used 16 electrons. So what you're going to do is you're going to get the total sum of valence electrons, which we found in step 1, which is 16, and we're going to subtract 16, which is the number of electrons we used. We get left over with 0. So now we have a problem, because the diagram isn't complete until all the atoms have a full octet. And obviously carbon doesn't have a full octet. Carbon only has 4 electrons, 2 from each bond, right? So how do we get more electrons? We can't just draw 2 more electrons or 4 more electrons, because then we would be using 20 electrons, but we only had 16 electrons to bond with, because only the valence electrons bond, right? So we can't do that. So at this point, the next step is that you're going to slide over lone pairs from your terminal atoms. So what I mean is I just deleted this lone pair on the oxygen that was on the right. I'm sliding it over here to carbon to form a bond. This is called a double bond. So when we talked about bond energy, which I believe was a couple of episodes ago, this is what I meant by single bond, double bond, triple bond. This is a double bond because there are 2 bonds between the carbon and the oxygen. So now they're sharing 4 electrons, right? Oxygen still has a full octet. It has 2 lone pairs, so that's 4, and 2 bonds, so that's another 4, so that's 8. Now, if you're noticing, carbon still doesn't have a full octet. It only has 6 electrons. So what we do is we're going to slide over a pair of electrons from the other oxygen. So we'll slide that over right over here, and boom. Now, you'll see that carbon does have a full octet. It has 8 electrons. Both of our oxygens still have 8 electrons, and if we count the total number of electrons, you'll see it's 16. 2, 4, 6, 8 on this side from the 2 bonds and the 2 lone pairs, and then 2, 4, 6, 8 on the other side from the 2 lone pairs and the 2 bonds. And that would be the complete Lewis diagram. So that's how you do it. That's it. That's all the steps. The hardest part is probably that sliding step. But yeah, one important thing that you should know, you will never get more than a triple bond. So it's not true in this example, but let's say for whatever reason we needed to slide another lone pair, right? Boom, this is a triple bond. You will never have a quadruple bond or higher. So you would never have something that looks like this, where you slide over all the electrons to form a quadruple bond. That cannot happen. The most you can have is a triple bond. So keep that in mind. So you either have a single bond, which is just 1 line, a double bond, which is 2 lines, or a triple bond, which is 3 lines. And that's it. And if you remember, a single bond has a bond order of 1, a double bond has a bond order of 2, and a triple bond has a bond order of 3. Now, one thing that you need to know as well for Lewis diagrams is how to draw ions. So it's actually very simple. It's really not that different. So let's say PO43 minus, the very famous polyatomic ion. So we're going to count our valence electrons. Phosphorus has 5, oxygen has 6, but we have 4 oxygens. And then an important thing here is to look at the charge. The charge is 3 minus, which means we have 3 extra electrons, so we get 3 extra electrons for valence. So you add 3 because of the 3 minus. Whenever you have a charge, you are going to add that amount of electrons if it's a negative charge, or subtract that amount of electrons if it is a positive charge. Here we have 3 minus as our charge, so we add 3 electrons. So if you do the math there, that sums to 32. So we have 32 valence electrons. So next we're going to choose. So that's step 1. Next, put the least electronegative atom in the center. So that's phosphorus. And then surround it with the oxygens, right? So O, 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 O. And then draw your bonds, right? And then next thing you do is you draw in your lone pairs on all of the terminal atoms, right? So we're going to fill in the octets on our terminal atoms. So we're going to give each oxygen 3 lone pairs because they need 6 more electrons. It's a little messy, but basically each oxygen has 3 lone pairs. Try to make yours look neater than this. And phosphorus, as you can see, has its full octet because it has 4 bonds, and each bond is 2 electrons, so that's 8 electrons. So if you count it all up, you'll notice that we have used all 32 electrons, and boom. Nice and simple, we don't need to do any sliding over, we're done, right? Well, not really. When you have an ion, there's one last thing you need to do. Whenever you have an ion, the Lewis diagram, you draw it like normal, but then you have to put brackets around it like I'm doing right here, and then you write the charge. So for us it was 3 minus, so you do those little brackets and you do 3 minus. That's the only difference. If you have an ion, do not forget to put your bracket and your charge. A lot of people lose points for this. Don't forget to do it. You have to do it, or else it's wrong. So now how to do that for ions. But besides that, that's really all we need to go over today. In the next few lessons, we'll be going over some exceptions to the rules we went over today. But don't worry about that stuff because we'll talk about it later. So I hope y'all enjoyed that. I hope it made sense, and I'll see you in the next one.